So back in January, I released my very first video on my YouTube channel related to 3D printing. And if you guys haven't seen that video is all about me unboxing and setting up my very first personal 3D printer that I got for use at home and for use on my projects related to my YouTube channel. And ever since I released that video, I've really wanted to involve 3D printing and film a lot more videos related to 3D printing here on my channel. And in the process of thinking of different videos and ideas to film to include on the channel, I thought it would be a great idea to start with a baseline video to talk about and discuss the very basics and fundamentals of what 3D printing is. It's still a relatively new technology, definitely has gotten more traction in I'd say the past 5 or so years, but still a lot of people maybe know what the basics are, or the very surface level information about 3D printing, but they don't know really how it works. So I thought it would be a great idea to film just a basics and fundamentals video to inform anybody who doesn't have a lot of background in 3D printing about what this really cool technology is all about. Now, if you guys are new to the channel, thank you so much for stopping by and checking out this video. If you guys like the content, I highly encourage you to check out the other content I have on my YouTube channel. As I mentioned, I'm going to be doing a ton more with 3D printing related videos. I do a lot with my homemade go-kart, my Corvette project, and just a lot of automotive related content in general. And as always, if you're a returning viewer, subscriber, thank you so much for your continued support on the channel. Now, we're all living in very interesting times right now. I'm sure I don't have to mention what that is, but basically the moral of the story is we have a lot of time on our hands. So that got me thinking this would be a great opportunity to film a video to really get anyone who's lightly interested in 3D printing a little bit more involved and maybe get a little bit more understanding of what the technology is all about. Previous 3D printing video, I actually talked about how I've been involved with 3D printing for quite some time now, ever since my good friend Will introduced me to it in college back in 2014 or so. And since then, I've gotten really interested in it, and I've done tons of different projects on it. I've done some classes on it. I did my thesis project in grad school on it, and now I'm actually doing it every day from my full-time job, working for an aerospace division of the Navy. So I thought this would be just a great opportunity for me to share my knowledge that I've learned over the years about 3D printing with you guys. And back in grad school, I actually did a small seminar and presentation to some foreign exchange students, and I put together a presentation to talk about the very basics of 3D printing to get people interested if they didn't know much about it. So that's what I'm going to go over today. Is I'm going to do kind of a voiceover as I walk you guys through that presentation, because I think it's a great way to learn the basics and fundamentals of 3D printing and kind of seeing some visuals to go along with it as I explain it. So I'm going to go ahead and hop on over to my computer and I'll do a voiceover of the presentation so you guys can learn a little bit more about 3D printing. Okay, so welcome everyone to the slideshow I've prepared for the basics and fundamentals of 3D printing. And I put this together while I was in grad school giving a seminar to Korean students visiting that wanted to learn more about 3D printing and different robotics and stuff like that. And I specialize in manufacturing and in particular 3D printing, so this was the content series that I put together to present to them. So I thought it was great content to reuse for the YouTube channel to give people that are interested in learning more about 3D printing and getting involved with it, the basics and fundamentals before they really get involved in some of the nitty-gritty parts. So here we go, 3D printing, otherwise known as additive manufacturing. That is another term that you'll hear thrown around a lot with 3D printing. Now to get started, just a quick outline. So I'll obviously be going over what is 3D printing, the origin of 3D printing, the 3 main types of 3D printing, different types of materials used, different applications, the overall process of 3D printing a part, and how to make your own 3D printed part given you have the tools and equipment that is needed. So to start, talk about the main manufacturing methods. Now, manufacturing can really be broken down into, I'd say, 3 different main categories, all the ones listed on the screen here. And some have been around a lot longer than others. But to start here, on the right, you have what's called subtractive manufacturing. And that's, as it sounds, you start with a solid block of material, oftentimes it's aluminum, and this has been around for quite some time. And so you mill or cut away at that solid block of material and subtract material off of the raw piece to get your final part that you want. Now in this type of manufacturing, you have a lot of chipping or chip material that you have to cut away, and there's a lot of wasted material. So it is a downside, but you can produce some really intricate and strong parts with subtractive manufacturing. The next, you have molding or casting, but a big one is injection molding. Now, casting and molding has been around for a very long time, probably since the early days of the Industrial Revolution. But most oftentimes today we see is injection molding. Now, any rapidly or mass-produced, especially plastic part, is most commonly injection molded. Now, they do have metal injection molding, but it's definitely not as common. Now, injection molding is basically as it sounds. You have a mold or a die, and that's hooked up to a machine, and molten plastic in the form of pellets that are usually melted down are pumped into the mold, and obviously then they will take the shape of that mold. And so it's a great way to rapidly produce parts very quickly, but it does have some drawbacks that I'll go over in a little bit. And then finally, we have additive manufacturing, otherwise known as 3D printing. Now, with 3D printing, there's a few different types of 3D printing, but the most common one, and the one that I'm involved with the most, is called FDM, or Fused Deposition Modeling. And I'll go into more detail on that in a little bit. So, to just start and get a little bit more involved with injection molding, as I said, plastic pellets are heated, melted, and then injected into a pre-made mold. Now, that mold is most of the time metal of some kind, whether it's aluminum, steel, really just depends. So you can see on the bottom left there is your main injection molding setup, where you have your a hopper and a auger that pushes and simultaneously melts the plastic as it pushes it and injects it into the pre-made mold. And it's like I said, a conventional way of making a large amount of parts in a quick amount of time. Now, this graph here is a very interesting graph to look at when you're comparing the amount of parts made versus the total costs. So the blue line indicates your 3D printed parts, and the red line indicates your injection molded parts. And so you can see that for injection molding, it's not very cost effective if you want to make a very low number of parts. And that is all to do with the mold, or tooling as it's called, that you have to make. So most of the time that tooling is subtractively manufactured or milled, and that can be very expensive. So if you're looking to only produce a very small amount of parts, like 25, somewhere around there, and that number varies depending on what you're making and whatnot, it's not very cost effective to injection mold stuff. So that's why really 3D printing has a niche market and area that it's useful for, because you can see that the cost to 3D print just one or a few parts is a lot less than the cost to injection mold one or just a few parts as well. So that's the trade-off that you see when you're looking at injection molding versus 3D printing. So it's really a case-by-case basis, but each have their place in the manufacturing world. So again, subtractive manufacturing here, this is an example of a mill turning down a wheel for a car. So you can see on the left, it starts as more of a solid block. Sometimes that's just cast, and then that's what gets sent to the wheel manufacturer. And you can see that the mill there is turning down the wheel in a different amount of passes. So you get, like you can see, a lot of different chipping material, so lots of material wasted because you can't really reuse that unless you send it to get recycled again. And then you can see in the bottom picture, you can see all the milling marks that the mill leaves as it cuts away material. So oftentimes they'll have to start with a bigger bit and then work your way down to a smaller bit to get more precise and fine details. So again, what is 3D printing, otherwise known as additive manufacturing? Well, 3D printing is really essentially 2D printing, but in multiple layers, doing it multiple times. So you have a block, or just, let's take a cube, just a simple cube for example, and you cut that cube into 200 layers. Well, 3D printing is printing each of those 200 layers multiple times on top of each other. And so you're basically creating something from nothing in a layer by layer fashion. So you start with your first layer, you extrude the material down, and then the printer moves up, and it keeps going up and up and up. So what is the origin of 3D printing? Well, the origin of 3D printing started with this RepRap project in 2005 from a guy named Dr. Adrian Boyer, I believe out in England. Yeah, he was a mechanical engineering professor at the University of Bath in England. Now, RepRap is replicating rapid prototyper. And the idea behind this project was he wanted to be able to create a machine where it could make and actually print and manufacture a majority of the parts used in the machine itself. So you basically have a machine that could build itself. And the project goal was to basically manufacture a majority of its parts on its own without complex machinery. So no, crazy mills or lathes involved. You can see here a lot of it are just simple rods and then hardware and fasteners that you could use with the 3D printed parts. And then you could rapidly produce prototype designs from the 3D models. So basically you could have a machine where if you want to make a part, it's a test part, you could quickly make it, test it in real life, and then go back, change the design, and do that multiple times or multiple iterations instead of having to wait to get it milled or injection molded. So there are three main types of 3D printing, as I hinted at before. The first being something called fused deposition modeling, and that's the most widely used. It's the one I do, the type of printer I have at home, and most of the ones I use at work and all my past projects. That's basically where you can see, as the top picture describes, you're extruding down a bead of the molten plastic, one line at a time, and then you stack those on top of each other. And the idea is that since it's hot, the plastic is going to fuse and melt together. The second type of 3D printing is more widely used, I'd say, by big-time manufacturers in the aerospace industry is selective laser sintering. That's where you have a bed of metal powder, but you can actually have plastic powder even sometimes, where you have a laser that basically melts the material on top of each other. And then finally you have something called stereolithography or SLA printing, and that uses a liquid or liquid plastic, or otherwise known as a resin, in a bed or vat of setup where it actually uses a UV light and it projects it in a specific pattern with a laser to harden the material, and then it slowly pulls the object out of the liquid bath, which is pretty cool. It's something out of like a sci-fi movie. It's really cool if you have the opportunity to see that. So a little bit more about how selective laser sintering works. You basically have a feed powder delivery chamber on the left there, and then you have your build chamber. So basically material goes up the feed chamber, a roller brings the material over to make sure it's a smooth layer. The laser then comes down and selectively hits a specific pattern based on that cut line of the part. And then you have a finished layer. The fabrication chamber then moves down, and then this repeats the process again. It brings more powder up, the roller brings it over, sinters it, this goes down, so on and so forth. And this material, or this type of printing, is great because the material that's surrounding your part in the build chamber is your support material. And you'll hear me talk about support material in more detail in the coming sections, but it's a great way to produce really intricate parts. And really strong parts as well, because most of the time you're using some type of metal powder. Oftentimes it's titanium. So you can see on the right here, this picture shows what the laser looks like as it's selectively hitting the part, and so you can kind of see the outline of the path that it's created already with the part that it hasn't hit and the part that it has hit. And actually this piece here on the bottom, since we're an automotive themed channel here, this is actually the brake caliper for the Bugatti Chiron. So it's got really complicated and intricate designs to help probably with heat dissipation. And you can see all of this support material that was left in the part to help support the overhanging features of the brake caliper. So this type of printing allows you, again, to produce really strong parts, robust parts that are going to see a lot of heat. The Bugatti Chiron's a really fast car, so it's going to need a lot of braking power to stop, and you can produce parts that are really intricate in their design as well. So again, going over selective laser sintering, the advantages being you can produce complex geometries without much needed support material, high strength materials, and high quality finished parts. Sometimes they do take a little bit of post-processing works, like some basic milling or sanding or blasting. The disadvantages are here that is very expensive. Most of the time you're only seeing big time companies like GE, for like GE Aviation. They make some aircraft parts. So it's a very expensive market, not something you're going to really see a hobbyist have, at least anytime soon. It's a limited printer market for the time. Only a certain amount of manufacturers make this, but there are more types of metal 3D printing coming out, which will be a later video I'll talk about. And this type of 3D printing is very time consuming. The laser takes quite a while to pass over each section. These layers are very thin, so there's many layers to print, so it's going to take a lot more time than your standard home printer that you have. So again, here on the top you can see this is a turbine for maybe a compressor wheel for a turbocharger. And then on the right here is actually something really cool. This is from a company called HRE Performance Wheels. They're local here to San Diego, but they really kind of brought to market the first 3D printed wheel for a high performance car. Now I think this wheel was proof of concept. I don't think it's actually in production yet, but it just shows you the level of intricacy you can achieve and strength you can achieve with this type of 3D printing. So now we move on to stereolithography. So this is another type of 3D printing. It's becoming more available to the hobbyist market, but still definitely not as popular as FDM. So with this type of printing, you again have a vat of liquid plastic or resin, and at the bottom of that vat is a UV laser that can selectively hit the point in the resin bath to harden the plastic layer by layer. So it's going to start at the base here, and then this chamber is going to slowly work its way up and pull the part out of the liquid bath, like you can see on the right here. And all these little extra patterns and supports is the support material to help the part maintain its structure while it's printing. And again, with this type of printing, you can produce really complex and intricate parts, such as this kind of mesh sphere that otherwise would be really difficult to print on other types of commonly used FDM printers. So stereolithography, again, the advantages: you can get complex geometries without a lot of additional support material. And the other big thing with stereolithography is you can get really high quality finished parts. With FDM printing, you'll see what are called layer lines, which I'll go over in another video in the future, which kind of makes the part maybe a little less high quality. But with stereolithography, you can't see any of the lines, how it slices the part in your finished part. So this type of printing is very popular in the medical world with different types of medical devices, or I've seen this used a lot in the dental industry for dental implants or test objects or test fixtures, things like that. Again, the disadvantages are this is a little bit more expensive than your standard FDM printing. It's a limited printer market. This is a printer called Formlabs, so they are one of the leaders in this SLA industry, but there's definitely not as many as your typical FDM printer. And right now, I think you're limited to certain types of polymers, although that is changing by the day. So now let's get involved in more detail with the most common type of 3D printing that I spend my time with and that you'll see mostly here on the channel. And that is again called Fused Deposition Modeling, or FDM. And that is where you're taking a type of filament, polymer filament, and it looks like a wire, and you're basically pulling it down and extruding it through a metal hot end, melting it, and then extruding it layer by layer in a bead-like fashion. So you can see this is your nozzle here that's very hot, depending on what type of material you're using, and then it deposits it in a bead-like fashion side by side and on top of each other. So again, you have your filament coming down, and in this case, this is called a direct drive setup, where your driving gear that grabs the material is right next to the extruder. A lot of times, the cheaper or more affordable entry-level FDM printers have a Bowden style drive system, where this driver motor is about 20 centimeters away, and it kind of pushes the filament into the hot end, versus in this setup, it'd be kind of pulling it. So you have your solid plastic coming in here, it's getting grabbed by the stepper motor, and then it goes into the hot end, it's melted, and then it comes out a very narrow bead. Most of the time you're talking about 4/10 of a millimeter, 3/10 of a millimeter, although some people even go up to 1 millimeter, but that's more rare. Most of the time you're going to see 4/10 of a millimeter nozzle size that you'll be printing with. So you have your hot end. Again, another basic description here. Hot end, extruding the material in a bead-like fashion next to each other and layer by layer on top of each other. So here are some advantages and disadvantages with FDM printing. So it's low cost, very affordable. I think Creality, which is the company of printer that I have, they have an entry-level printer called the Ender 3, and there are even some maybe DIY kits that are cheaper, but their entry-level printer I think is about 180, 200 bucks, and it's a very powerful printer that can do quite a lot for the price. So within the past few years, these printers have come down a lot in cost, making them very affordable and very enticing for the hobbyist market. That brings me into the next point. This is a large printer market. There are tons of different manufacturers out there. A lot of them use similar designs. Others use better designs than others, but that'll be a whole nother video kind of talking about what are some of the best entry-level printers that you can get. Another advantage is it allows you to quickly prototype parts to use for your designs and your projects. So if you need to print it, test it, and see if it fits well or see how it feels and if someone's going to be using the part in their hand, it allows you to go in, quickly change the design in a matter of hours or a day, print another part with those design changes incorporated. There's a project I'm working on right now where I've probably had to change the design 5 or 6 times, and I'm able to print a part within 5 or 6 parts in a matter of a day to keep checking on how this design is progressing and if it's going to work. The disadvantages with this type of printing technology is that there's limited print geometries, at least that you can do without support material. So you can see here on the right, this is like a basic dog here that you're going to be printing, and any area that has an overhang that isn't touching your build surface is going to need support material, because otherwise you can't print into thin air. So the downside with this is you use a little bit more material, and the surface of your finished part where this support material is contacting the part is going to be a little bit rougher. In this case here, this looks to be an Ultimaker printer. You can see a thin layer of white material in between the red. That's most likely a dissolvable PVA material, so you can put it in warm water and this will actually dissolve away, so it won't leave a rough finish on your part. But that's a little bit more intricate. You need 2 nozzles to achieve that, so you're not going to really see that on an entry-level printer. The next disadvantage is you're limited a little bit to strength on your printed parts. That has come a long way. You're able to now print with higher end and higher strength parts that are even infused with carbon fiber, Kevlar, but some of the more common ones is like PETG is very strong, which is what single-use water bottles are made out of, ABS, polycarbonate. I'll get into more details of those in the coming slides. And then you're, again, limited to certain types of polymers based on the type of printer you have. So getting into the materials a little bit more detail, there's various kinds of materials, but the most common by far material that you're going to see with FDM type of printing is called PLA. Now that's polylactic acid. It's a very easy plastic to print with. Low printer temperatures makes it very easy for the printer to achieve, and it's not very difficult to print either. Some other materials like ABS have difficulty with warping issues and heat dissipation while it's printing. There's 6 really main types of materials or materials used with FDM printers. PLA, as I mentioned, ABS, so that's the type of plastic that you see with like black drainage pipe you see at Home Depot or Lowe's. You have nylon, so anything like parachute cord, that's nylon, and there's many different types of nylon. You have PETG, which is what all your single-use water bottles are made out of. HIPS, you have polypropylene and polycarbonate. So those are some the main and most common types of filament materials used with FDM printing. Now again, this will go into a further video talking in more detail, but some of my favorite materials to print with are PLA, just because it's so easy, it's very cheap, great for prototyping parts. And my next favorite has been PETG so far, because you get a really strong part. It's also very affordable. Doesn't require a lot of high temperatures, so you can do this with a lower end printer, and these parts are durable to outside use. So any type of car item or thing that sees UV, it's going to be a lot more resistant to break down. But that'll be a whole nother video talking in more detail about the different types of materials you can use with your FDM printer. So those are just the basics. So 3D printing applications, what are the applications? Well, really almost anything that you can think of. There's a lot of automotive applications. You can see there is an engine block prototype. That's a V6 it looks like. So a lot of car manufacturers will 3D print on their large scale 3D printers. These types of parts to fit check them to make sure everything fits in the package that they're going to inside the car or inside the engine bay. Another common area you might have seen 3D printing used is prosthetic limbs. Again, you can really customize these designs. No one person has the same geometry and shape and size. So you can't really use injection molding necessarily in this case because these parts need to be so custom based on the user's height, arm length, things like that. So it allows you to make some really intricate parts that can even be robotically controlled nowadays. And that leads into the next area is robotics. You can 3D print a lot of different robotic arms and actuators and joints. And then with the stronger SLS style printing with metal, you've even seen now different aerospace parts. Aerospace grade parts made out of titanium are probably flying on the commercial jets that you fly on today, produced by GE and other companies too. And 3D printing has even made its way into the medical world, not just with medical devices, but actually we're seeing 3D printed organs as well. This was kind of an area I did in one of my classes, was that a company, I don't know exactly who or what the status is now, but they were looking at printing organs in a way that they could use cell scaffolding to keep the organ alive and then inject it with a person's unique DNA so that the organ wouldn't reject the body, or the body wouldn't reject the organ, because anybody who has to go get organ transplants has to take anti-rejection medication so their body and their immune system doesn't reject their organ. So it's a very cool technology, very up and coming, a great topic to get involved with if you're looking for something to specialize in school or major in. So it's a really cool technology, and new progress is made every day. So what is the process of making a 3D printed part? Well, step one, you're either going to find a design online. There's a lot of cool sites called Thingiverse. There's a site called Thingiverse where you can actually download free designs other people have made. But say, for instance, you want to make something from scratch yourself. Well, you're going to have to start with a CAD software, a 3D CAD software. The one I use most of the time is called SolidWorks. There's another one called Creo. And there are many different other versions as well that are free to use online. Another one that a lot of people use in the hobbyist or maker industry is Autodesk Fusion 360. And I believe, don't quote me on this, but I believe it is free to students. So if you have a .edu email account, you can get a free version, and it's a very powerful software. Has a little bit of a learning curve, but you can get over it and slowly learn. So you're going to design your object in CAD, in any type of CAD program. Then you're going to export that design as a special type of file called a .stl file. Now, STL is relates to the triangulated shape or mesh that the part is made with when you export it. So this is kind of how it puts the design from CAD into a language that the printer can understand, or this is kind of the intermediate step you'll see. From there, once you have your STL file, you import that into what's called a slicer software. Now, each printer, depending on what printer you're using, is going to use a different type of slicer software, whether it's proprietary to that manufacturer or it's open source based on your choosing. But most commonly, the one that I use and that I've seen used with most printers, FDM style, is a software called Cura. And that is where you take your STL file, you import the STL, so you can see a little robot guy here, and this is where you set all of your settings on your printer. And again, this will be a whole nother video, is optimizing your settings, what all these settings mean, because there are definitely a lot. But you set your material type, you set your printing temperature, which is most commonly based on your material. You set your nozzle size, your printing speed, your layer height. So the smaller your layer height, the more high resolution and high quality your print is. You can set your print density, so how dense your part is and how thick and heavy it's going to be. So just things like that is what you adjust in this type of slicer software. And the software does exactly as what it's kind of coined as, is it slices the model into those 200-300 layers to basically give the printer a GPS roadmap on where to go for each layer. So this is what you can see here. This is what a slicer software does, is it interpolates a curved object, because anybody who knows basic, if you did Riemann sums in basic calculus, is there's no perfect curve in the world. A curve is basically an approximated series of rectangles, and that's what the slicer software does, and that's how your computer monitor works, or a TV. You have your pixels, so it approximates it based on the amount of pixels. So the slicer software is going to make all these little steps to make an approximated curve, and if you print a higher resolution object, you're not going to see these steps as much. But if you print at lower resolution for quicker printing, for prototyping, you're going to see these steps a little bit more in curved objects that you print. So again, here, this is your basic design process with 3D printing. You do a 3D printed CAD model. That brings it in, and then you export that as an STL or triangulated file. You bring that into your slicer software, and that slices it into many different layers, or the old term mostly with CNC is tool paths. That creates your tool path for the printer. You then put that on an SD card, or you can send it right to the printer via USB cable, and then it's going to print your final part. So I kind of already touched on this, but you're going to adjust all the settings in your slicer software, the material being used, print density. So higher infill is going to obviously use more material. It's going to take longer to print. And then this is where also your software is going to, based on the algorithm and the coding behind the software, it's going to analyze where in your model are you going to need support material based on the overhang length. So for this object here, this is like a little 3D benchy test print. Sometimes, you know, if you have an overhang in this doorway, you might need support material there. In this case, you don't, because this doorway is arched, so it can slowly close that gap. But if the gap between each side is long enough, you'll have to use support material to hold up the middle of the extruded plastic in the middle to keep it from drooping. So finally, you save your part there to a SD card most of the time. You insert that in your printer. And then your printer, depending on what printer you have, is going to have a menu. This looks like a monoprice printer, but then you're going to select, you can adjust a lot of different settings on your printer itself, but then you're going to select the SD card and the file you want based on what you saved it as, and you start the print. And it's going to go ahead and start the print for you and start building it layer by layer. So that's going to do it for the basics and fundamentals of 3D printing. I hope that wasn't too wordy or involved for some of you. I just kind of tried to stick to the basics and not get too in-depth, but also not be too surfacey as well. So if you guys have any questions or comments, please feel free to leave them in the comment section below, and I'll be happy to answer them. If you guys have any suggestions on future videos for ideas, please feel free to leave them in the comment section below, and I will definitely do my best to take those into consideration. So thank you guys all so much for watching. Make sure you guys subscribe for more 3D printing videos to come on my channel here, as well as all sorts of other projects related to my go-kart, my Corvette, and things like that. And make sure you guys follow me on Facebook and Instagram for more behind-the-scenes stuff. My handle is @nat_automotive. So I post a lot of cool photos of maybe my design work in CAD, 3D printing stuff, and just stuff you don't necessarily see on the YouTube channel. So thanks guys for watching. I really appreciate your time. Hope you guys enjoyed it, found it useful, and learned something. And other than that, I will see you guys in the next video.